form product. Right? See, the molecules react and the product is formed. Right? So products are formed when this reactants, the molecules of the reactant, they collide. And there is a process of breaking older bonds and the process of forming new bonds. Right? So we break old bonds in this product creation process. Like for example, I have reactant, from that I'm going for a product. So I need to break old bonds and I need to create new bonds. Please note, this is just a theory, right, that this may be happening. Now the process of breaking the old bonds, it requires energy. This need energy. The old bonds will not be broken on its own. Somebody has to provide energy. So the reaction to happen, actually, the molecules should collide with each other, as we have seen here. The molecules colliding, and they should collide at a proper orientation, and they should have energy that is greater than the threshold energy, and that threshold energy should be able to break the old bond. And that's what I'm saying, that they should have energy. There is a threshold energy, and these molecules, they should have energies greater than the threshold energy, and then only they can collide and they can break the old bond, because we're talking about breaking old bonds, creating new bonds. So to break something, we need energy, right? So the minimum energy to break a bond is my threshold energy. So these molecules, when they are colliding, they should have a minimum energy to break and to form product. If these guys don't have minimum energy, the collision will happen, but the collision will not be effective. It's like if I'm to break a wall, I have to hit hard with the hammer. Even if I hit in a light way, the wall will not be broken. Right? It has to be very hard hit, and that hard hit is nothing but the extra energy which we are providing to break the wall. Same thing, when we are creating a new product, I'm breaking the old bond, creating a new bond. To break the old bond, I need energy. The minimum amount of energy that is required to break the old bond is my threshold energy. Right? So the reactant should acquire a minimum amount of energy to convert this into product. And this energy is called activation energy. Right? The energy that is required to start the reaction is called activation energy, and this term was introduced by Arrhenius itself in 1889 to explain his concept. Right? So minimum energy required to start a reaction is called a what? Activation energy. Its unit is kilojoules per mole. Example, you have this bomb, but if you just keep the bomb, it won't burst. You need small amount of energy. Small fire can burst this bomb, right? This small fire will provide the activation energy for the bomb to burst. Same thing in the gas, right? So we have a gas, LPG gas, but it won't light on its own. You need the lighter, and lighter provides a small amount of energy. This is spark, and with that spark, then everything works fine on its own. So small amount of energy, right, that is required to start a reaction is called my activation energy. So as per Arrhenius, for a reaction to happen, he's saying the collision has to be there and it has to be strong, right? And it should produce a reaction. But if you see the two cars, they are going in a slow direction, they will not produce a huge bang and the product will not be formed. There has to be a huge bang. Let me repeat once again. Two cars coming with a high speed, there is a bang. And this bang means a collision happened, right? And then the product will be formed. But if the two cars are coming at a slow speed, they will bang, but not with that impact will not be there. It will be just ouch. The product will not be formed. So they should have energy. These cars should have energy, activation energy to break, right? One more understanding of the activation energy concept is like this. You are on this hill, right? you want to throw this ball. But actually, if you see, if there is no shape like this, you can actually just a small push will, or the ball will roll on its own. Actually, if there is no hill like this, the ball will roll on its own. But if you see this state and this state, this has less energy. If we talk about the potential energy from physics point, this has more energy. Correct? So typically everything wants to go from more energy state to lower energy state. If I keep a ball here just in the air, it will come down on its own, because here we have more potential energy, here you have less potential energy. Right? On its own it will go down. Delta H will be less, right? Spontaneous reaction. But here if you see, there is a structure, there is a hindrance. So this extra energy, if you pass to this ball, if you keep this ball somewhere here, the ball will then roll on its own. So this extra energy is the activation energy. Hope you are understanding. The ball here is position 1 and here we have position 2. At position 1 has more energy than the ball at position 2. Typically, if there is no hindrance, ball will on its own go to position 2, because the potential energy at position 2 is less. But because the hindrance, ball is not able to go. If you want ball to move from 1 to 2, that is more energy to a lower energy state, or I can say this is my reactant and this is my product. So generally, if delta H is less than 0, my product has more energy, and that's why delta H is less than 0, right, for a given reaction. For a reaction reactant to product, if delta H is less than 0, that means my product is more stable than reactant. And that's why the reaction happens, right? The whole purpose of the reaction is that they want to be more stable. Because the hindrance, the ball will not be able to go. But if you provide this extra energy, and that is nothing but activation energy, the ball will be able to go. This is my reactant. Reactant will not form products on its own, because in the hindrance, if you provide the extra energy, that is the hindrance, activation energy, then the reactant will by default automatically become product. That is the concept. If you see now from the chemistry perspective, let's suppose this is my reactant and they have some 50 kilojoule energy, and the product by default will have, let's suppose, less, here 30 kilojoule of energy. So by default the product should go to reactant on its own, but that is not what it happens, right? You need to provide some energy to start the reaction. We have seen that the bomb also, it doesn't blast on its own. There has to be some energy provided. Then if you see delta H is negative, that means it is a spontaneous reaction. It should happen on its own, but it doesn't happen. Most of the case, it doesn't happen. We have to provide some energy. And why it is not happening? Because the curve is something like this. And why it is like this? Because if you see, we'll see in the next slide, when you go from reactant to product, there is something called active-unit complex that is formed. That is the intermediate step that has more energy. So it is like a mountain here. You have to cross this mountain, and this energy which you have to provide is called threshold energy barrier. So if you can just cross this threshold energy barrier, you'll by default go at this level, similar to the ball rolling example. If you can somehow provide this value, then it will go on its own. So this extra energy is called the activation energy of the forward reaction. If it is equilibrium kind of reaction, will have the forward activation energy for the backward reaction also, and that will be nothing but threshold barrier minus the energy of the product. Here it is threshold barrier minus energy of the reactant. So in this case, this is 115 kilojoule minus 50. That is, this value is nothing but 65 kilojoule. And this value is 115 minus 30. That is 85 kilojoule. If you see, activation energy of forward reaction is less than backward reaction. That means, and that's why the reaction moves in the forward direction, because you need more energy to push the reaction to backward direction. So if you have reactant and product in the equilibrium kind of thing, so to push reaction in the forward direction, you need 65 kilojoule of energy, and to push reaction in the backward direction, you need 85 kilojoule of energy. You need more energy to push reaction in the backward direction, and that's why the reaction moves in the forward direction, because you need lesser energy to move the reaction in the forward direction, right? This is my reaction coordinate progress, and this is my energies actually. Hope you understand. This is my reactant, this is my product. Delta H is less than 0. Product will have less energy as compared to reactant. By default, reaction should happen on its own, but it doesn't happen. We have seen this, right? The bomb doesn't blast on its own. It needs a spark. And that does nothing but activation energy. These are all theories. It came because of the observation in the real world. In the real world, it is seen that the reaction, part of the reaction doesn't happen on its own. They need some push, and this is the push. And this push is nothing but my activation energy. Please note, activation energy for the forward direction is the difference between the threshold energy and the energy of the reactant. Activation energy is not 115 kilojoule. In this case, the threshold energy is 115 kilojoule, but the reactant already had 50 kilojoule of energy. So the difference it was lacking was only 65 kilojoule. Correct? Reactant already had 65 kilojoule of energy, but it needed 115 kilojoule of energy. So the difference is my activation energy. The extra energy that is required for the reactant to move into product is my activation energy. Okay, so we'll take some example for this. For example, hydrogen plus iodine becomes HI, right? So if you see this step, similar step here. Here I have a hydrogen molecule, here I have iodine molecule, right? Now when hydrogen and iodine combine, if you see, they come to each other. These bonds break. These bonds, old bonds will break and new bonds will be formed. If you see, the new bonds are formed and the old bonds will break. Correct? So the breaking of bonds will require energy. So this complex which you see, this is the complex we call, this is called activated complex, right? So it is proposed, again this is proposed that this activated complex is formed when my hydrogen iodine molecule collide, and this activated complex has more energy. It needs more energy. You see, if this has some, gives some value here, I don't know the actual value of this. So let's suppose this is x and this is x plus y. So if you see, there's a difference of y kilojoule. Let's suppose this is in kilojoule. This is typical energy, right? Kilojoule per mole. So extra y kilojoule per mole energy is required because this activated complex has more energy. It requires more energy, and this is a little unstable. And this is formed only when they collide at proper orientation. And this complex is formed for a short duration. And then this breaks. Once this is here, it breaks and it becomes, the old bond breaks. And if you see, my HI is formed now, 2 HI, right? This is 1 HI, this is 1 HI, 2 HI formed. Correct? If you see, this is my hydrogen iodine, this is my final product HI. Hydrogen iodide, they have lesser energy than my reactant. So there is a delta H. So delta H is negative. But still, the reaction doesn't happen on its own. It needs some spark. Why? Why it needs some spark? Because it is proposed now. It needs a spark. That is the experimental data. Why it needs a spark is a theoretical concept. It is said that they form a complex. And this complex has more energy. Right? It forms a complex. This is a complex it forms. And then this complex is formed for a very short duration and then it breaks, right? So assume that this energy of the activated complex here is EC in this case. So this value is EC, x plus y. And energy of the reactant is X, that is ER. So my threshold energy or activation energy is nothing but EC minus ER. That is EC is nothing but, if you see, is the threshold value of the activated complex, and that is nothing but x plus y here. And energy of reactant we have seen is X. Subtract this, you get Y. So Y is the extra energy. This is the extra energy. This only extra energy is my activation energy, right? So activation energy is nothing but the extra energy required to start the reaction. For the backward reaction you just saw, it will be this threshold energy minus this value, that is energy of product. This is energy of reactant. So for EA or backward reaction, will be EC minus energy of product. And this will be even less than X, you see, right? So we have shown that this energy activation or backward direction is more actually, and that's why the reaction moves in forward direction. So I don't want to repeat the concept once again. This is just an example of the concept which we just explained in the last slide. Okay, so we can also define activation energy as the extra energy required to form the complex intermediate. Correct. Note that in almost all the graphs which we draw, if A is here, the product will be lesser. The product will have lesser energy than the reactant, because we are talking only about spontaneous reaction for which delta H is less than 0. So it will always be something like this. This is reactant, this is product. There has to be some delta H. For a complex reaction which happens in multi-step, so if you see, there will be humps like this. Correct? So this will be my step 1, step 2, step 3. Now all these steps will have some energy of activation energy. The maximum activation energy will be the activation energy of the complex reaction. The maximum activation energy of the slowest step, or the slowest step will have the maximum activation energy, obviously by default, right? Because that is slowest because it has maximum activation energy. So slowest step will have max EA, right? And the max EA will become EA of complex reaction. Max EA of any step. So let's suppose this is a complex reaction. It happens in 3 steps. It will have humps like this. Obviously, to cross this hump, it will take more energy, right? High threshold value. So this will be slowest step, and that's how it happens.